All right, so far we talked about blockchain technology. Now it is time to talk about cryptocurrencies because Bitcoin started it all. So first, our aim is to talk about Bitcoin, understand the internal parts of it. Then later on, we will talk about alternative coins, which means any cryptocurrency other than Bitcoin, actually. So this is the definition of alternative cryptocurrencies. So let's start with basic definitions that we have already talked about before. Let's remember them. Blockchains are tamper-evident and tamper-resistant digital ledgers implemented in a distributed fashion and usually without a central authority. And in cryptocurrencies, most of the time we don't have a central authority. Sometimes we have some non-profit organization that actually, regulates that cryptocurrency. So they enable a community of users to record transactions in a shared ledger. No transaction can be changed once published. In 2008, the blockchain idea was combined with several other technologies to create modern cryptocurrencies. So this is why we have to start with Bitcoin to understand how every other cryptocurrency or other blockchains works. Yeah, the first such blockchain-based cryptocurrency was Bitcoin. Within the Bitcoin blockchain, information representing electronic cash is attached to a digital address. Bitcoin users can digitally sign and transfer rights to that information to another user, and the Bitcoin blockchain records this transfer publicly, allowing all participants of the network to independently verify the validity of the transactions. So here's actually, this sentence explains almost everything. So when you transfer Bitcoin, actually, you are not transferring it from one place to other. You're only signing a transaction which actually proves that you had the authority, you were the owner of that cryptocurrency, and now you are saying that it belongs to this public key address. That's it. So this is what the transaction is, okay? So you prove that it belongs to you, and here, as you can see, in order to make such a proof, we should use digital signatures. So this is where crypto comes into play. So you are actually signing a transaction which actually transfers the ownership of those cryptocurrencies from you to some other person, and everybody in the network checks if the signature is correct. So if the signature is correct, you are proving that you had the authority. And now you are saying that somebody who can prove that they have the private key to this public key actually now owns it. Okay, that person may not be even connected to the network. They may not even know that you made such a transaction at all. The Bitcoin blockchain is stored, maintained, and collaboratively managed by a distributed group of participants. You can simply download Bitcoin Core and install it on your laptop if you have at least 500 gigabytes, because currently the blockchain size is more than 430 gigabytes. So everybody can download it, which actually stores every transaction from the beginning, the Genesis block, to the end. Of course, since most of the money transferred since the beginning, you don't have to store all of those spent money. So actually, when you install the software, you can say that I will only reserve, for instance, 10 gigabytes of my hard drive. So you only store the last 10 gigabytes and also the unspent transactions that is way back in the past, okay? So you don't have to store the whole thing, but of course, for full security, we always suggest to have a copy of the whole blockchain. Otherwise, you start trusting other people. So this is the reason. This, along with certain cryptographic mechanisms, makes the blockchain resilient to attempts to alter the ledger later. As you can see, here we are talking about integrity, and here cryptographic hash functions comes into play. In Bitcoin, the blockchain enabled users to be pseudo-anonymous. So you are not anonymous, but you're pseudo-anonymous. This means that users are anonymous, but their account identifiers are not. Additionally, all transactions are publicly visible. So this is the important thing, because people think that everything is encrypted, so nobody can see what happened in the blockchain. On the contrary, nothing is encrypted. Everything is publicly visible. You can look at the blockchain at any time and see from which account how much Bitcoin is transferred to which account. So account identifiers, everybody can see it, but what we don't know is that we don't know to whom that account belongs to. This is why we say it's pseudo-anonymous. This has effectively enabled Bitcoin to offer pseudo-anonymity because accounts can be created without any identification or authorization process. Such processes are typically required by know your customer laws. So this is why when you can download the software and create a wallet address, but if you want to exchange it using the crypto exchange web pages, you have to obey this know your customer laws. So you have to provide your identity and so on. Most of the time, you take a photo of you with your identity card next to your head, and so people think that this is enough. Since Bitcoin was pseudonymous, it was essential to have mechanisms to create trust in an environment where users could not be easily identified. And actually, this is the thing. Most of the time, we don't know almost 99% of the network, right? Because we don't know which accounts belongs to whom. But of course, this doesn't mean that you always have to be pseudonymous, because, for instance, if you want to accept some donation, you can simply put your Bitcoin address, tweet it, and pin it so that everybody will know that that account belongs to you, right? So in forensics, you should have some methods to scan web pages to check actually which account belongs to who. Okay. The use of blockchain enabled Bitcoin to be implemented in a distributed fashion such that no single user controlled electronic cash and no single point of failure exists. This promoted its use. So this is the technology that one of the technologies Bitcoin use. In other words, the distributed method of implementation actually allows us to use this kind of system. Otherwise, we would have a single point of failure. Its primary benefit was to enable direct transactions between users without the need for a trusted third party. So initially, when there were no crypto exchange web pages, what you did actually to meet people in person and transfer your cryptocurrency to their address. For instance, you meet at a cafe and you do it with your laptops and take the money as cash in person, so that actually you don't need authority at all, right? So this is like selling a used equipment or something, right? But of course, in the past, we always promoted this. This was the main idea. This was the cypherpunk idea, so that you don't need to have a third party or government or anything. But now that the prices are really high, you can do this for money laundering. So this is why it is not a good idea to meet with people in cafes and buy cryptocurrencies, because those money may not be obtained in a legal way. Okay. It also enabled the issuance of new cryptocurrency in a defined manner to those users who manage to publish new blocks and maintain copies of the ledger. Such users are called miners in Bitcoin. So now Ethereum moved on to proof of stake. So there we don't have miners, but we call them delegators, or sometimes call them with different names. In that scenario, they stake some money, but they still earn money. So they earn it by by the system where it is minted as the new cryptocurrency. The automated payment of miners enables distributed administration of the system without the need to organize. So this is why it is automatic. When a new block is added, actually the person who added is rewarded, so you don't have to deal with anything else. By using a blockchain and consensus-based maintenance, a self-policing mechanism was created that ensured that only valid transactions and blocks were added to the blockchain, right? So you have the consensus, but of course you have to implement the software in a correct way, so that every node checks if it is correct, and then they say that yes, we can add this block to the blockchain. So cryptographers are really angry about the using the word of crypto, because like 7 or 9 years ago, when you Google crypto, the first thing you will see would be the crypto conference that is held since 1980s in the United States, mostly in Santa Barbara. Nowadays, when you type crypto, you will just see, Bitcoin or Ethereum prices, right? So they steal the world from us. So when I say that I'm a cryptographer, people think that I, buying and selling Bitcoin. So this also applies to, many news. So in this news, for instance, the stadium is name is changed to crypto due to some, agreement. But that crypto is not cryptography. It is used for cryptocurrency. So this is also important because a lot of people start to use crypto for cryptocurrencies, but in every dictionary, crypto means shortened version of cryptography. But if a lot of people use the word crypto, not for cryptography, artificial intelligence also starts to think like that. So when you ask ChatGPT, it wouldn't understand that you're talking about cryptography. It will think that you will talking about cryptocurrencies. So this is why actually, you cannot create human-like artificial intelligence because they will always be, misguided by majority, let's say. All right, so let's move on to Bitcoin. It is peer-to-peer electronic cash. This term is used in the white paper. So it was proposed in 2008. You can download the white paper from Bitcoin.org. Just you can click this link and you will see that it is a very simple document, but explains almost everything in a very simple way. So here Satoshi talks about why it works, why it should work, and how big the blockchain size will be after how many years, and is it possible to perform the 51% attack, which means that if a large part of the participants behave in a bad manner, with what probability they can perform an attack and so on. So Satoshi actually calculates all of this stuff. So this is why we will talk about it, but when we make a transaction in Bitcoin, it takes 10 minutes, but we still wait an hour. So this means that we wait for 6 blocks just to be sure that it is really recorded in the blockchain. These all come back to the calculations from this white paper. So everybody should read it at some point in their life if they're really interested in cryptocurrencies. Decentralized, every node in the network keeps a copy of the ledger. So everybody has every transaction since the beginning. All accounts and transactions are public. So this is the surprising thing for a lot of people, because people think that crypto means cryptography and cryptography means encryption. So if this is a cryptocurrency, then everything must be encrypted. So this is the big surprise. So there is no encryption in Bitcoin, in Ethereum, or any similar cryptocurrencies, okay? People think that it is block ciphers are used and data is encrypted, but no. This is why we haven't talked about encryption in this lecture, because we don't need it, okay? Of course, in a permissions blockchain, you might store some data in an encrypted way if you want, but in most of these public blockchains like cryptocurrencies, almost no encryption is observed so far. So then question is, if it is not encryption, then why we use cryptographic algorithms? We use cryptographic hash functions for the integrity of the ledgers, the blocks and also transactions. We also use cryptographic hash functions in mining puzzles to prevent double spending. And to send Bitcoins, a transaction has to be authorized. You have to prove that you are the owner. So we use digital signatures there. So these are the cryptographic algorithms we use. And this is why we call them cryptocurrencies. That is the whole reason. Pseudo-anonymity, account numbers are cryptographically obtained values and do not contain personal information. So there is a huge open question asking, can we have a cryptocurrency which is full anonymous? So where you cannot track the transactions at all. The answer is yes, okay? With zero case, zero coin, and then ZK snarks and ZK starks, we observed many possibilities. We will talk about them in the future, but the simple version of summarizing how it works is that when you make a transaction, actually you are putting it, it looks like from the outside, it looks like as if you are putting it in a pool. So when people send money to each other, actually it is gathered in a pool. And when you look at it, you can see the total amount sometimes, but you don't know which one belongs to whom. And at some point of time, since somebody sent you that amount of cryptocurrency, you come and say that, okay, I had this amount of cryptocurrency. And you prove it with zero knowledge protocols. So that amount of cryptocurrency now transferred to you from the pool. So this is how you hide the transaction. So this provides full anonymity. Okay, we will talk more about them in the future. So let's go back to Bitcoin. Bitcoin is the first implementation of a concept called cryptocurrency, which was first described in 1998 by Wei Dai on the cypherpunks mailing list, suggesting the idea of a new form of money that uses cryptography to control its creation and transactions rather than a central authority. So this is why this kind of ideas also cited in the white paper of Satoshi. The first Bitcoin specification and proof of concept was published in 2009, actually the first week of 2009, in a cryptography mailing list by Satoshi Nakamoto. So nobody knows if this is a real name or a fake name. Actually, there are this kind of names, Japanese names, but some people think that it is, just some words from famous companies like, Toshi is the first part of Toshiba, Sai is the Samsung, you can just combine that kind of companies and you can create such a name. But of course, that might be also something people invented since nobody could find who the real Satoshi is. Satoshi left the project in late 2010 without revealing much about himself. So he said that, he is going to, I'm saying he, but of course we don't know his gender, but he said that he's going to focus on some other projects. So he left the source code to other developers with the, password to the repository and left the scene, and we haven't heard from him yet. So the community has since grown exponentially with many developers working on Bitcoin. The Bitcoin protocol and software are published openly, and any developer around the world can review the code or make their own modified version of the Bitcoin software, which I strongly suggest. If you want to create your own blockchain, just modify the Bitcoin blockchain because it is the basic version. Of course, if you want a blockchain that has the capabilities like Ethereum, then you have to modify the Ethereum, of course. But for simple ideas, I always encourage people to modify the Bitcoin blockchain, but it is not an easy job. Okay. So one of the questions, who controls the Bitcoin network? Nobody owns the Bitcoin network, much like no one owns the technology behind email. This is important because people think that initially when Bitcoin was started in 2009, we tried to convince economists that it really works. Okay, and they say that no money can occur without a central authority. You cannot transfer them without a central authority. They say that this is impossible. So we try to explain the cryptography behind it. But once you come to digital signatures and elliptic curves, they say that they don't understand it. So they say that this is a scam. So they thought that one day Satoshi will come and steal all of your Bitcoins. But this is also the same thing as saying that the people who invented email one day come and read all of your emails. So this is not correct, okay? This is just a technology and we are using it. Nobody owns it, okay? Of course, economists didn't believe us and, they always said bad things about cryptocurrencies until 2014. In 2014, the prices of Bitcoin or similar cryptocurrencies are really increased. So at that point, still economists didn't try to understand how it works, but they realized that it is around and it is not going to disappear soon. So they started to give investment advice for cryptocurrencies, but most of them, they still don't know how it works. But people who were, actually had some sense in the beginning said that this is a technology that not everybody understands. So just be precautious, but, it looks like it works. This is some economists who are, interested in technology actually realize that it is really going to be a thing in the future. So Bitcoin is controlled by all Bitcoin users around the world. while developers are improving the software, they can't force a change in the Bitcoin protocol because all users are free to choose what software and version they use. So this is the difference. You can create an update, but people may not install it. And this has actually happened with the SegWit update, which we are going to talk in the following slides. So developers couldn't convince miners to install it for a few years. Okay, and at the end they agreed to install it for a completely different reason. Okay, because in the initial version, when you have FPGAs for mining, sorry, ASICs for mining, there was a trick which could boost your mining performance with 20%. And if somebody uses that technique, we could actually realize it once they mine the block, by the way. So this actually caused an uproar. And with the SegWit update, actually people will not be able to use that property. So this is why everybody agreed to move on to SegWit update. Not for all of the properties or new properties that the update introduces, but they just agreed because they thought that some other people will be using the same hardware as they are, but they will be mining with 20% faster. So this is the whole reason they updated. So this is, I'm just trying to prove that nobody owns or controls it. Okay, developers are, I mean, huge influence, but they cannot force you to do it. Actually, this is the strange thing. This also applies to for Ethereum, Bitcoin, or many other technologies. These developers actually, affect the history. The changes they do are really important. But if you look to their Twitter accounts, you will see that they have only like 100 followers or something. But people who give cryptocurrency investment advice has sometimes millions of followers, right? So actually, this is why people have wrong ideas about all of these topics. So this is why you cannot find some people who can explain what a Bitcoin is and how it works. In order to stay compatible with each other, all users need to use software complying with the same rules. Bitcoin can only work correctly with a complete consensus among all users. Therefore, all users and developers have a strong incentive to protect this consensus. This is one of the reasons the system works, actually. So how does Bitcoin work? Behind the scenes, the Bitcoin network is sharing a public ledger called the blockchain. This ledger contains every transaction ever processed, allowing a user's computer to verify the validity of each transaction. The authenticity of each transaction is protected by digital signatures corresponding to the sending addresses, allowing all users to have full control over sending Bitcoins from their own Bitcoin addresses. Okay, so you cannot steal other people's Bitcoin if you don't have the private key of their public key. In addition, anyone can process transactions using the computing power of specialized hardware and earn a reward in Bitcoins for this service, which is referred to as mining, which we'll be talking about in the future. So can Bitcoin scale to become a major payment network? So this is one of the things, again, economists doesn't understand. So some people claim that instead of Visa or MasterCard, in the future, we will use Bitcoin. Currently, we cannot do it, actually. It is not that scalable. So let me try to explain why this is the case. The Bitcoin network can already process a much higher number of transactions per second than it does today. It is, however, not entirely ready to scale to the level of major credit card networks. Work is underway to lift current limitations, and future requirements are well known. Since inception, every aspect of Bitcoin network has been in continuous process of maturation, optimization, and specialization, and it should be expected to remain that way for some years to come. So we should have many updates in order for this to be, an alternative for a Visa or MasterCard, but still you cannot do it without a hard fork because a block is written in every 10 minutes. Think about, getting a pizza or getting a beer at the bar. You have to wait for 10 minutes to be sure that it is written in the blockchain, right? You cannot just pay it and leave. So this is why it cannot be used for that kind of transaction. But of course, the main idea was to, transfer money to somebody around the world without paying any fees, but making it in a very fast way. Because if you do use something like Swift, you have to wait days for it to happen. And if some problem occurs, you have to pay some money to figure out why it didn't happen and so on. So it is not an, I mean, still sending money, like sending $20 to somebody in the United States from Turkey is not an easy job, right? So cryptocurrencies actually solves this problem. As traffic grows, more Bitcoin users may use lightweight clients and full network nodes may become a more specialized service. Most probably in some cryptocurrencies, people will move on to like Amazon web services and so on, instead of keeping their own servers for this kind of operations. So here's a picture which probably from last year, showing that average transactions per block. So this is 7-day average, by the way. As you can see, in some blocks there are more than 2,000 transactions, but sometimes we see around 1,500 transactions. So it depends on the network traffic. If people start to, I mean, due to some events, for instance, here people make more transactions, here people do less transactions. But as you can see, this is around 2,000, right, for a single block. Think about Master or Visa cards. In a special day, like Black Friday or something, a store actually does that kind of transactions in a few minutes, right? Think about the whole world in that sense. So, Bitcoin scalability today. Bitcoin block size is set to 1 megabyte, but this is theoretically now 4 megabyte due to SegWit upgrade, which I will explain later. But this means that you cannot write more than 1 megabyte to the block itself, right? And average Bitcoin transaction size is around this many bytes, 380 bytes. So this is a traditional pay-to-public key hash transaction, which we'll also again see in the future. But a regular transaction has this many bytes because, as you can see, it contains the information about input and output, but you also sign it. The signature is the biggest part of this size. So this is also an important topic. Short signatures is a topic in cryptography, and in the future, most probably we will see that kind of algorithms to be implemented, most probably in Ethereum, to make things smaller, because Ethereum blockchain increases in a very fast way the size. So in the future, we might need extra hard drives to store all of the blockchain. But let's make a simple calculation. So the block size is 1 megabyte, so it is this many bytes, and we are saying that one transaction is around this many bytes. So if you divide it, you can put around 2,760 many transactions per block. And a block is written in 10 minutes. So if you divide it for 600 seconds, this number divided by 600 means that you can actually have around 5 transactions per second. So this is what I was saying. This number is around close to 2,000 transactions per second on Visa. Right? This is why you cannot compete with Visa with Bitcoin. So, of course, these numbers increases all the time, and without changing how the Bitcoin works, you cannot increase this number to this, right? I mean, you can make it 10 with some modifications, and actually with the SegWit upgrade, this is we can have more than 5 transactions per second, but we cannot make it more than 1,000 with a simple upgrade, right? So this is why the scalability is not that easy. So since I mentioned there was an upgrade or update called SegWit, this means that we can actually provide new properties or updates to Bitcoin. So how this works? So this is called Bitcoin Improvement Proposal, or BIP. Anybody can recommend adjustments, improvements, and additions to the Bitcoin environment. They are called Bitcoin Improvement Proposals. BIPs became active when the entire community gives mutual consent by adopting the proposal. This means that they install your upgrade. That's it. You can review all the BIPs. There are many different ideas. Most of them are not used, and some of them causes big changes in the system, which we will refer to them as hard forks. And actually, Bitcoin always try to avoid hard forks. Okay, and we will explain this when we talk about forking. Let's go back to hash functions. Sorry, go back to Bitcoin and what kind of cryptographic algorithms are used in Bitcoin. Let's look at the hash functions. In a blockchain, hash functions can be used for address derivation, securing the block header, securing block data. Here, by securing, we are actually saying that it shows the integrity, so it provides tamper resistance. So this is why the blockchain becomes tamper evident. Hash functions also used for creating unique identifiers or creating cryptographic puzzles. In Bitcoin, this cryptographic puzzle uses SHA-256. And in Ethereum, it uses SHA-3, but nowadays, it no longer supports mining, so you use proof of stake. There are many hash functions in the past. We already talked about this. MD4, MD5, and SHA-1 are broken due to collisions. The RIPE MD160 is the only remaining short output algorithm that we have. This is why actually Bitcoin uses this algorithm, because hashing is used to compress the public key of users. So this way we have shorter addresses. Okay. But we also have secure other algorithms, SHA-2 and 3. SHA-2 is extensively used in Bitcoin, and SHA-3 is used in Ethereum. So Bitcoin script allows the use of SHA-1, RIPE MD160, and SHA-256, but actually every version of SHA-2 is allowed in Bitcoin. So I say SHA-256 here because it is the most used version, but you can also use SHA-512 in Bitcoin if you want. So this is the tricky part. As you can see, developers of Bitcoin, in other words, Satoshi, realizes that there is a theoretical attack for SHA-1, which is not experimentally performed. So he realizes that in the future, this might cause a problem. This is why he includes RIPE MD, and it is used extensively. So this is also surprising because at the time of the invention of Bitcoin, RIPE MD were known only to cryptographers in Europe. So this gives an idea, either Satoshi is from Europe or he has very close friends who work on this topic, okay? If he's American, he should have gotten this idea from a European person. Because around 2008, nobody in the United States had an idea about this algorithm. So Bitcoin's choice of cryptographic algorithms, as I mentioned, for the hash functions, we have SHA-1, SHA-2. I think I should replace this instead of SHA-256. I should write SHA-2 here, but also RIPE MD160. But SHA-1 is not used for security. So although there are collisions for SHA-1, it doesn't affect the security of Bitcoin because it is not used directly in any place. Digital signatures. So far, we had elliptic curve digital signature algorithm, which we have already discussed. But in the last update via BIP 340, which became active 2 years ago, 14th November of 2021. So with this update, now Schnorr signatures are allowed. Schnorr signatures should be preferred instead of elliptic curve digital signatures because Schnorr signatures allows multiple signatures. It allows signature aggregation. This means that when 3 people want to create a multi-signature transaction, if you use ECDSA, 3 people have to sign it, so you need 3 signatures. In the Schnorr, you can combine these 3 people's signing keys, so that it looks like a single key and you sign with it. So at the end, you actually sign with a single key. So you can aggregate the keys and it appears like a single key. So this way, the transaction sizes are shortened for multi-signatures. So you might also ask that if this is so fantastic, why we initially used elliptic curve digital signatures. At the time of Bitcoin's invention, Schnorr was patented and its patents expired around the time Bitcoin started. So elliptic curve digital signature algorithm around 2008 were used by a lot of people. So people were confident that it was secure. But Schnorr signatures were patented around that time, until that time. So there weren't much confidence in the security of the algorithm. This is why Satoshi actually chose elliptic curve digital signature algorithm. But now that the patent has expired, people added it to Bitcoin, and this is why, transactions fees are somewhat smaller if you use this kind of signatures. So let's recall Bitcoin's elliptic curve. By the way, both of them uses an elliptic curve. So here, both of these algorithms use the same elliptic curve. So we only added this property, but didn't change the elliptic curve at all. So instead of this digital signature algorithm, you use Schnorr signatures, still using the SECP 256K1 elliptic curve chosen by Bitcoin. So Bitcoin uses this elliptic curve. It wasn't a NIST standard. It was a standard by Certicom. You can see this document. At that time, it wasn't a NIST standard. And in the latest document of NIST, which published 1 or 2 months ago, they added this elliptic curve in the appendix so that people can use it for interoperability. So let's recall the definition. Elliptic curve is chosen as y squared equals to x cubed plus 7. This means that b is chosen as 7 and a is chosen as 0. This is why we don't see any x here. Defined over fp, the field here p is a prime and p is chosen as this. All points on this curve are valid Bitcoin public keys. In hexadecimal, p is this. So this subtractions only modifies these parts, as you can see. Base point g is this. So the first part of it is the x coordinates, and the second part is the y coordinate, but we use the x coordinate for address generation. The order of this point is this. So actually, you can have this many different public keys for using Bitcoin or Ethereum, because both of these elliptic curves are used in Bitcoin and Ethereum, but almost in every cryptocurrency, this elliptic curve is used. So when you are signing a transaction since 2021, November, you can either sign it with elliptic curve digital signature algorithm or Schnorr signature algorithm. So your software should allow you to choose that. If you use a node wallet, that software will only use elliptic curve digital signature.